Doing good.
Sorry, I was saying I was good, but I forgot my mic was turned off. I was like, I'm doing good, and then you like asked again, like, how are you doing? I'm like, oh, sorry, my.
One of these days, you're gonna, get that fit.
Yeah, one of these days, but I mean, saving up for different things, college students.
What are you, coach?
The budget, something there.
Getting married.
Yeah.
Ooh. When are you getting married?
I'm not getting married till like July, so.
Oh, it's still quite a ways. Yeah.
So a while.
It's not a whole lot of time to put together a lot of money, though.
Don't scare them.
Yeah, luckily next semester, for winter semester, I'm just staying here, but I'm off track, and at my job, they're allowing me to work 40 hours a week, and so I'll just be working full time.
Very nice.
So I'll be making around like $700 a week, which will be nice for like a college student.
Yeah, definitely.
Not a week. That's like for 2 weeks. Sorry. But yeah,
not bad.
It's not like great or anything, but I mean, it'll help me save up for marriage or adulting.
Adult, it's always good. Hey, real quick. Wait, hold on. What does that say? So I'm working on that. Why is that saying that? On the margin of error and the reject or not reject.
Mm-hmm.
What was so if it's less than, so if the p-value is less than, what if it's equal? Less than or equal?
I don't think we ever addressed that.
So does equal go above or below? Or we've never really, maybe that's just not going to happen. So
if it's less than the
so it's less than the
less than or equal to the alpha.
To the alpha.
So it has to be greater than to not fit that.
Mm-hmm.
So it's less than or equal to the alpha. Then what happens?
Then we reject, right?
Reject the null. If it's less than?
Yeah.
Yeah.
Reject the null hypothesis, right?
Yes.
Okay, and if it's greater than, then we
fail to reject.
To reject the null hypothesis.
Oh boy, Dodgers losing.
Yes, the woohoo! Top 7. Dodgers.
Okay.
Houston's up 5-1 in Game 7. Woohoo!
Hey, we're not done yet.
So, and then the confidence level, the alpha is just the confidence level minus 1, right? Or 1 minus the confidence level. So if it's a 95% confidence, then it's usually 0.05.
Yes.
Yeah. So 1 minus 0.05 or 0.0 whatever the.
I'm just trying to make it for. I'm trying to make it for this. To just work in this thing, so we don't have to. So essentially, it can work.
So you don't have to think about it.
Yeah. So I'm just trying to trying to make this thing work here. Real quick. See, that is going to awesome. That's going to go to F23. F1, that's not going to work. Oh well, we'll fix it. Nice catch, turkey. That's J23 and I23. Ooh, it worked. Gee, I guessed right. Nice.
Ooh, wow. Normal probability app. It's organic.
That did not work. So I made an I. Yeah, that's right. If I, no, it's 23. That's why. Come on, guys. You should know that. Sorry, give me.
Sorry, I'm just. Loading,
have this done.
downloading all the file that we need for our.
So the p-value is greater than we should fail to reject, correct?
Yeah.
Right.
Okay, I'm just doing a little test to make sure my math is working here, and it works. Okay, that's beautiful. And do we do that in the? We don't do that in the ANOVA, do we? Yes, we do. We do that in the ANOVA or no?
It works differently though, but you still kind of give whether
Do we do in the ANOVA? Do we still do the margin of error?
Margin of error. Let me see. Oh, where's my link?
I'm trying to think. Well, let me just send this. I'll send this to you what I have right now, and I can always tweak it a little more. But I think this will help with the test just on simple things, because we know how to do it. It's a matter of, saving a little time.
No, there's no margin of error on ANOVA.
Okay, so I'm going to send you guys this file. So I think I can send it through the Google chat we're in. Let me see. I should be able to attach a file, right?
Yeah. Or
I think, or I'll email it if I can. Where did I put that? Desktop somewhere. Isn't that it? No, there it is, fixed. Okay. Unable to attach file. No, I can't. So let me.
so just email it to us.
Yeah, let me see if I can find our last. Where's our last class thing? There it is. Oh, that's the Hangout. Link posted. Where's our last email? Control chat.
Let me check.
So looking at my Google and it's all chat, chat, chat.
Oh, so it's in the Gmail account email, not on our.
Right. Let me see if I can just read. Gavin. No, see, I don't have. It doesn't show me the email address.
Hold on, I got it here. Let me see.
Just yeah, send a quick test or send a quick message.
Just a sec. But I think, hold on, who's here? The other one. You just need to
What email are you in, Bradley?
Well, I was in my Gmail, so I guess I should look at my school mail, huh? Is that?
Because yeah, the Math 221A group email has your BYUI email.
Okay, let me look at that. Maybe that's why I'm not finding us.
And what's your
Type mine in the group chat.
Oh, there we go. Okay, let me reply to all and attach this. Oh, it's just
so
sending.
it's THO 16066. Is that yours?
Yeah, everyone else is Samuel. There you are. No. Okay, that's your Gmail. Okay, and then I have Marie, and then I have.
Mine is more 160. Can't remember my email. 16068. MOR 16068.
Gavin, is that Ethan? Ethan, Gavin, Ethan?
No, that's the wrong one. That's the other one.
Oh, yeah.
Where's
Mine's Gavin Brown.
Oh, wow.
Is it the RO 13019?
Okay,
Yeah.
so I just sent those. I just sent that to you guys. Go ahead,
Okay.
check it out. It's pretty rudimentary as far as like I didn't make it suit my. Maria will be able to attest to this that I didn't make it up to the standards, whatever that word, whatever they use.
The standard of professionalism.
It's not quite the standards of professionalism, but it works. So.
Hey, it's just us, so that's fine.
But no, I mean, I've been meaning to do that, and I knew it just takes me like 5 minutes to do. But to me, that's going to be super helpful to me because I'll mix them up other ways. So, and please quickly, let's test it as we go through this, just to make sure, you know.
Okay, let me see. I haven't got it.
Let's not believe me 100% quite yet, but I did test it on each one, and it did work. So, but let's start going through. If you guys want to look in your emails for that. But let's start going through.
Email it to my Gmail.
Our test. I believe so. I think everyone else's were. Well, no, I think I did it to Gavin's. Gavin, I think I sent it to your BYU address.
Yeah, I got it in my Gmail.
Yeah, I'll check it. I'll check my BYUI address really quick.
Yeah, Gavin, it was your BYU address. You know, it's crazy. If you start typing people's name in, if you put your BYU Idaho address in Outlook, and you just start typing people's names in, it has every student in the address book.
Wow.
Yep. Okay.
So I hope that was the right Gavin. Pretty sure it was.
No, yeah, you're good. She said, from what was said with my email, like, it seemed correct.
Awesome. Okay. Let me share my screen here. And are we sure we can't take the test together too, really?
No, unfortunately not.
As long as we don't record it and post it on the school website.
We're gonna be in trouble. It's recording right now.
You guys don't want to see my work stuff? It's very funny. Where's my login here? There we go. I learned.
Hold on.
I gotta say, anybody who wants to take
It's a
this database course, CIT.
okay. It's 5-1.
Boo.
Yeah.
Not as fun as it sounds.
Okay. Bye.
If anyone thinks that sounds fun, it's not. I'm not liking that class at all.
I won't sign up for that one then.
The CIT 111, it's a database course. I just took it as an elective because I'm like computers and I actually like databases, but I just don't like how they have it laid out. It's not a very fun. Anyways, not very fun. Well, these are awesome. I know.
Accounting. The second accounting, right?
I have not taken it yet. I think I might take it this next semester.
Oh, okay.
Now that I finished the first accounting and the 2 econs, but I've not taken the second accounting because the first time I took accounting and econ in the same semester, and that was brutal.
How was
That's why I spread it out.
What was that, Sam?
How was the second econ class?
I did not like it as much. The first one I liked better. There was a lot of what do you call it? Overlap.
Okay.
But I did not like how it was taught, and I don't know if that's more to say with my teacher or if that's more to say with the class. I don't know, but I just did not like it as well as I liked
the first one.
The first one, yeah.
Yeah, Econ 150 is a lot about like supply and demand and just like that normal stuff. But then 151 is where you get into like all the more complicated and like advanced things.
Yeah, a little bit more weird math. But just, and again, the one thing I don't like about econ in general, to me, it feels like they take simple concepts, make up a bunch of confusing words and definitions, and make themselves sound smarter. You know?
Right.
Like,
things that you already decide on yourself, anyways.
Yeah. So, all right, let's get rolling here. Poor Dodgers. So
hey, knock it off.
given a 90% confidence interval of 40 and 105 for a mean heart rate, which of the following is best interpretation of this confidence interval? Wow, this is a while ago. I'm not even like ringing a bell with this 45, 105 thing.
These are the same questions, right? The ones that we were doing?
Yeah, the review.
Where'd my paper go?
Lesson 15 review, I think, right?
Yeah.
There it is. Oops.
Oh, that's never mind. I get what you're saying. Sorry. So we're 95% confidence that the true mean heart rate is between 45 and 105.
Was it D?
So mine is
it
D.
C, isn't it?
I put D on mine.
Wait, hold on. The true mean, right? Yeah, because the true mean is the whole population, and that's what we're testing for, right?
Or wait. I don't think those are the same ones that I had in my... I mean, it's the same question, but I think they're in a different order now.
Maybe.
No, that's pretty much.
It's not the same. It is the same order?
Uh-huh.
Because I put D, but the answer
Oh,
that I wrote...
hold on, no.
Yeah, because the D in the review is what I put, but the answer is not D in that.
No, it's the it's the C, I believe.
It is C, so Brad, you are right.
Yeah. Yeah, it got they reversed it.
Yeah, I think they're probably mixing it up. So they're not exactly the same, but they're the same questions. Okay. Using the following information to answer the next two questions, and we can all read that. So our question is, are the requirements constructing a confidence interval satisfied? And they want us to do QQ, right? We need to determine whether the interval QQ plots for both random samples.
So there's 20 females and 15 males.
The go, no go stimulus requires that suitors.
I wasn't sure, but I just guessed the one that the size isn't large enough.
Just some
First one?
Yeah, but I don't really know.
Yeah, because wasn't it, what was it like? Was it 30 that they had to be bigger than? That was considered
greater than 30.
That was what the teacher said, but it never said that in the book.
Right, but I'll trust. But the book was vague. I'll take 30, right?
So is that what we want to go with as the first one then?
Yeah.
Well, hold on. Wait. But doesn't it say right here that they see that they're approximately normal in the QQ plots?
Oh, let me see the Q.
Yeah.
If it's that, would that maybe be C then? Yes, the distribution of the mean of each sample is normal size. The data has been determined to be normal.
It could be.
Right. I just see that because they say the QQ plot is normal.
Yeah.
So QQ plot is normal, and
So if the data is normal, then the sample should be normal, right? I mean, isn't that, it's only, we 100% know if it's normal with the large sample size because it'll always normalize.
Yeah, that's true.
But they are saying that it is normal. That's what I think. I mean.
That makes sense.
We good with that for now?
Yep.
We have 2 tries at it, right?
That's right. And we have 4 of us.
yeah.
4 types of confidence intervals listed below. Which one is appropriate for this experiment? Which we review.
Confidence.
We have the 20 and 15. It is a.
It's independent, right?
Independent.
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 So we're saying it's the third?
Yes.
C, I should say?
Yes.
I think it's the same. So
Okay.
30 customer.
Question 5. So we have a 95% confidence interval, sample size of 30, which is now officially considered large, right? And
95%
which of the following
confidence interval.
interval with a smaller margin of error than this 95% confidence interval? Which of the following would produce a confidence interval with a smaller margin of error than the 95% confidence interval?
I think it's the last one.
A larger sample size, upping the confidence interval.
I think I agree with saying
Yeah,
that
obtain the balance.
the 90 bank customer rather than 30.
Right, 'cause you can't just say computer 99% confidence interval. You can't just magically make that happen, right?
Oh, well, doesn't that make it bigger? Or make it more, a bigger
It's
p-value?
narrower.
Mm.
The more sample size you have, the narrower
Yeah.
the intervals or the
And
margin
when-
of errors.
You know, I just look like on one of the sample tests, if you just change your confidence level to 0.99, it does not affect the p-value at all.
No.
Yeah, doesn't it make it a bigger range?
Well,
Mhm.
I'm saying, but so B definitely doesn't affect the. Oh, we're looking at the margin of error though, right? Hold on.
Yeah, but I think when you have a higher confidence interval, I think that makes the range or the margin of error, I think it makes it bigger rather than smaller.
Yes, it does. 100% it does. You are
Which
correct.
means it's not that one.
Who's texting me? What's going on? Oh, another ground ball for the Dodgers, and the Dodgers are out in the bottom of the 7th. So sad.
It's okay.
Going to the top 8. Going top 8, down 5-1. Loving it. Okay, so I agree. Yes, the D sounds right to me.
All right.
All right, on to number 6, and we have a new.
So we're D on number 5.
D, correct. So we're talking about a factory, propeller, drive shafts, meant to be 1,000 millimeters. We know the norm distribution standard deviation is 2 millimeters with a 95% confidence. Okay, so determine the margin of error for this 95% confidence interval.
Oh, that's
So we have
the
1,000.
2.
Golly, this is the one that now I'm starting to having to remember all these.
I think that's the 2. He posted a video on that.
Is this one of the ones he did the video? What's so let's remind ourselves what the equation is here.
So the equation there is so we're covering.
So here we have a known sample mean.
Our
Right, of
standard deviation is known, right?
Yeah, and a standard deviation. So we know that the standard deviation is 2. We know the sample mean is 1,000, and we know our confidence interval. I'm gonna add this to my Excel sheet if I can.
Standard deviation is 2 mm.
So so if we can find the what do you call? If we can do the, you guys can help me remembering the equation here.
Yeah, just a sec.
I'm gonna set this up here. What was the color they always had us use in the was it yellow?
Isn't it
Sorry, was it
N is equals? You have a question?
real quick? Wasn't it yellow that they always wanted us to use for the things you enter? Right? Isn't on that Excel in the standard professionalism? Isn't it yellow?
Yeah.
That he always had us
The
use?
input cell?
Yes.
Yeah.
I'm just sort of trying to make this semi-simple here, but okay. Sorry about that. Let's go. So okay. So what's our equation look like? So our equation.
So is it the n? Go ahead.
No, you go ahead. I'm listening.
N is equals to z times standard deviation divided by m, which is the margin of. Oh no, that one.
Was it the square root of n?
We're trying to find the margin, but we don't know n.
Square root of n.
Oh, that's right.
We don't know n, and we don't know. All we know is the sample mean, the deviation, and the confidence level, and we're trying to find the margin of error. That's the only knowns that we have.
So.
Okay, just a second.
Oh wait, no. Well, I mean, we do have 4. Randomly selects 4 drive shafts.
Is there 4 in there?
Yeah, it's not written as a number, it's written as a word.
Oh, so we do have 4. Okay, so it is, sorry, we do know n. N is 4.
N is 4.
Hold on, let me fix this.
So,
Oh, come on.
so we can do
Oh my goodness.
z times
Okay, so
standard deviation divided by square root of n.
4.
Yeah.
No, this is not pretty, but it's gonna work. Dang it.
No, what's RZ?
So
With the 95, I want to say the z was 1.96, wasn't it?
Okay, yeah, oh yeah. 1.96 times standard deviation of 2 divided by
Divided by 2.
34.
okay, so golly, this is where I wish we had like
2.
Google Chat had a better way.
2 divided by 2 is 1. 1.96 times 1 is equals 1.96.
So then
1.96 times
2 over 2.
2 over 2.
Yeah, because it.
But I need the whole equation real quick because I'm trying to do an Excel sheet. So
it's times
They're losing.
2 over square root of 4.
okay, so
It's still 5.
but it's times the standard deviation
Right.
I'm on my email, my meeting.
over
Divided by square root n.
Top of the 8th. Sorry, my boys just came home.
Do we not do anything with the sample mean then?
Well, I think you take, once you get the margin of, oh, well, maybe it's in the next question?
Well, I'm just
So
asking.
the question is the margin of error, right? It's asking?
My question is did the sample mean ever come into play
Not on that one, I don't think.
on this?
Let's see. But it will be in the next question.
Okay, so what we're saying here is that should be 0.196 then, right?
It's our margin of error, yes.
Margin of error. Okay, and if that's standard deviation. Okay, so it just happens to be a nice round number because it's essentially 1.96 times 1, right? Because it's 4 over the square, or 2 over the square root of 4, which is 2.
Which is 1.
Which is 1. Okay, so but I did add that little, okay, so I added that little thing. So okay, so right now we have 1.96. Whew. Input the lower bound.
Then
So
you
this
take,
is where we say the sample mean minus 1.96, right?
Mm-hmm.
Hold on, so let me lower, upper, down. I'm just adding these in.
Is it the 1,000 minus 1.6?
1.96, but yeah.
1.96. So it's 998.04.
Right. It has to be 3 decimal places, so we just need to remember to put that last
0.
040, 998,040, and 1001.96.0. And by the way, again, I am, when I'm done, I guess when we're done with this test, I'll send you guys my final draft of this. So I'm just adding a few extra tweaks to this while we're doing it.
Sweet.
Okay. Next question, number 9. To assess the accuracy of the laboratory scale, Standard weighted to 1 grams repeatedly, weighed a total 10 times. So now, the question is, how large should n be so that the confidence interval of the mean is the margin of error of plus or minus 0.0001?
Oh, that's the margin of error?
This is the margin of error when the n is unknown. So we're trying to find the. So our margin of error is plus or minus 0.0001. So we're trying to find n.
N.
Find that the sample size formula.
Okay, n. Where's the n? N is equals to z times a standard deviation divided by margin of error raised to the second power times 2. Is that the right equation?
That's what I'm looking for. Okay, so yeah, this is the n equals, you said z.
N is equals to z times standard deviation divided by the margin of error.
And there's a 2 in there, isn't there? God, it is a 2.
Yeah, times, it's open and close parenthesis time, 2 on the top.
Okay, so hold on 1 second here. So we're going to do, in this case, we're going to do another one here. So we know what the margin of error is.
Is
In
equals
this case,
to
it's 0.0001. We know what the
z times
confidence
2 divided by n.
interval is, which is 0.95. And we know, standard deviation, right? We know the standard deviation.
Standard deviation is 0.01.
And then, is that all we know right now?
Standard deviation is 0.01.
You have a
And
weight of 1 gram. Does that matter or no?
the z is the one 95%. What is the z for the 95%?
Okay. So our equation should look like this then, right? We should say n equals, oops, sorry, I lost the, where did that equation go?
1.96.
Shoot. I wish they would just write these much easier.
So 1.96. So the margin of error is times.
Hold on, I'm going to see if I can find a better version of this equation.
By
That equation is very
0.0001.
changing.
1.96 times 0.01. 0.096 divided by point.
So the 1.96 thing, that's only if you're on a 0.9, or that's only if you're on a 95.
196.
Right?
Yes.
N is 196.
Okay, I'm lost.
The N is 196.
I totally trust your calculation. I'm just trying to wrap my head around the equation. Sorry, and I'm not having good luck on it. But we don't need to dwell on that. Okay, because we know that. Let me just get through this real quick. So we know that. Shoot, I'm sorry. Sample size is z, which z is. Sorry, I'm having a brain fart here. What does z stand for in this equation?
Z is the 95% interval, which is 1.96.
Okay, so it's the 1.96
times the standard deviation of 0.01.
Okay, times that.
Divided by 0.0001.
And that's all of that is divided by, right? So like, so 1.96 times
Oh, hold on.
the standard deviation is
I gotta
above.
do the times 2. Hold on, just a sec. You still need to do it on times 2.
Where's the times 2 at? That's sorry.
You divide everything, then you do the times 2.
Okay, so it's the 1.96 times the standard deviation, all that divided by the margin of error.
Let me send you the
margin of error, then all that times 2, correct?
Yeah.
What? Then that's times 2. You got 392. No.
That's what I came out of.
392. Okay.
So, I don't want to throw a wrench in things, but as far as I can tell, it looks like the problem that we did on the review is exactly the same, and there's a multiple choice answer.
What do you mean?
But I mean, we're not getting any of the 4 choices.
Okay, so what were those answers?
The first is 1,960. B is 12,988. C is 38,416. And D is 45,455.
Okay.
Hold on. So I have a different equation here. I have a different equation that says n equals, hold on, z divided by, divided by, and then it's all squared, not times 2. Maybe, is it squared?
Oh, yes, squared.
Maybe that's where we're getting
196 times.
That makes 38,416. So that doesn't sound right either, right?
38,000.
496 times.
That is the letter C.
38,416. Yes.
Okay. So it's squared, not times.
Yeah, sorry. My bad.
Oh, you're good.
Squared.
Okay. Next question. The mean area of mu, isn't that mu? Am I saying that right? The little u, okay, is advertised to be 1250 square feet. The tenant group thinks the apartments are smaller than advertised. They hired an engineer, The appropriate null and alternative hypothesis are what? So the null is 1250, but they're saying smaller, right? Or,
yeah, so it should be the last one, right?
Is it?
Yeah. So the first one says it's equal to 1250, and the null says it's less than 1250.
So what are we asking here? It's if it's the advertisement.
Yeah. So it says that. So the one people says it's 1,250 square feet. The tenant group thinks it's smaller than that. So it's asking us what is our hypothesis, and so it should be D. It's either equal to or less than is the alternative. I agree.
Okay.
And then I think the 11 is the p-value is less than alpha.
Right. We reject the null.
I had that too, that the p is less than alpha.
Oops.
Okay.
Group of students want to determine if
We use ANOVA hypothesis testing for this question. Okay.
I don't remember what I said for that.
For this one, I was
Oh,
thinking
it's that. That's the.
What was that, Gavin?
I said for this one, I think it was C.
Is enough that the data for each apartment building are L-shaped.
The data for each apartment building are L-shaped with no outliers, and the sample variance are nearly equal.
Sounds good to me.
ANOVA. C?
Yeah.
Can they use ANOVA? Are you watching it online, little guy? Ninth inning. Dodgers loser. Sorry.
So my question. Okay, I'm sorry. I'm so on ANOVA tests. Okay, so I guess it's yes because we also have multiple variable. I guess even though we're asking the same questions, since we have the 4 apartment buildings, that gives us kind of the forced variables, right? That's why we can use the ANOVA. It's not just one deal.
Yeah.
Okay. Okay, I agree with C. Okay. Medical researcher team, our question is, in a future study, is determined that any treatment does not increase the mean survival time.
Gosh, you guys are so quiet.
The research has, okay, it is one of those ones that, what kind of error are we committing here? So let's everyone read through this real quick.
Tries. Small results are rejects the null.
Oh, forgot to eat it.
That one I think was a type 1, right?
Nah, I'm good.
Well, I'll heat it up. I'll heat it, yeah.
When you mistakenly reject.
Quite frankly, I'd have to look at my notes. It's been so long since I looked at the type 1 and type 2 errors.
I think that the type 1 was when you mistakenly reject one. And then type 2 was when you don't reject and you should have.
Is everybody agreeing with type 1 there?
Yeah.
Okay.
If any future study that treatment does not increase.
If the level of significance of alpha is made very small, therefore making the probability of committing type 1 error very small, what happens to the probability of committing a type 2 error?
Increase the probability.
That's A, right?
Yeah.
Yeah, because they're inversely correlated.
Yep.
Okay. The nicotine content of cigarettes, the mu, standard deviation of 0.17.
Nope.
Is this
So
evidence?
it is evidence.
Actually higher than advertised. To answer this question, test the null hypothesis. Test the hypothesis 1.5 or is it greater than 1.5 at the 0.05 level of significance. You conclude that what?
That is higher.
So saying that the standard deviation is 0.17, the brand advertises contents of 1.5, measurements are at 1.53. So X bar is 1.53, the regular is 1.5, the standard deviation, I mean, that's within standard deviation, but is it within that 0.05 alpha?
The mean is 1.5.
Can you manually enter these? No, that'll screw it up.
And then 100. The N is 100. And so the answer then has to height 0.5. Level of significance 0.05.
100.
So
Mean is standard deviation 7.
margin of error is
We're saying it's correct, right? So I'm getting a p-value of 0.04. So that's reject the null.
Yeah.
I believe that is what I'm.
it's number.
I just went into that one sample test and I just manually changed the variables to fit, and then I'm just going to undo it because it breaks your formulas. And that's what I got a p-value. 0.0403, and our alpha is 0.05.
So it's number 1 or A?
Or D.
Oh, it's the alternative. Okay, it's the null. Is the
Yeah, reject the null hypothesis. Undo. There we go. Bottom of the 9th. Last chance for the Dodgers.
Don't worry, they're losers.
Just so you guys know, let's just real quick. If you guys go into your sample t-test on that Excel sheet, you can manually change the numbers and on the variable line and on like the null hypothesis line, and it will give you p-values and all that stuff. You just have to remember to undo your changes because it breaks essentially it breaks your things. But that's a good quick way to test those because all the formulas are in there correctly. You just
Which one? Which the one that you emailed us?
Yeah, so you just go to the very first page and just change his variables on, like you can go in and change the null hypothesis to 10, which you could do all with. Put it greater than, but then you can go into the end and type in, I went into the end and typed in 100, and I went to the mean and just typed them in, put the mean at 1.53 and put the standard deviation at 0.17. And it fills everything out for you. It does break the spreadsheet, so you have to undo those when you get your answer because you don't want to break it. Does that make sense? Kind of manually override. Anyways, just saying that might help real quick in a pinch. Okay, so that rejects the null. 16. You would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 of each group. If those means are different, what is the correct statistical procedure? So is that a pair? No, hold on. Yeah. Independent sample t-test? It's not paired, right?
Yeah, it's independent because it doesn't. When you pick the male students, it doesn't give you any idea of which female students will be picked.
Exactly. So is that an independent samples t-test? Is that the right one?
Yeah.
Okay.
Everybody good with that?
That little guy.
Everybody good with 3 more outs for the Dodgers? Okay, sorry.
Sorry.
Okay, so 16 we said B. 17. Should she use a hypothesis test based on independent or dependent sampling? Brothers and sisters raised in the same home. Yep, so that must be dependent, right? Because they have to be brother and sister?
Yeah.
So I think, well, let me think here. Yeah, because they're pairing the same academic support, so that matters. If they're brother and sister, they want to see, does that matter within that home? So the brother does matter to the sister and vice versa.
But it's not the one that depends to some degree on her brother's academic achievement. It's the last one.
So it's the last one, yes, I agree.
Yeah.
The delta.
If you select brothers, okay.
Number 18. Random soil samples. Of the 4 types of confidence intervals listed below, which one is appropriate for this situation? So we
use
random sample soils measured to dissolve this thing. The measurement is recorded. The researcher would like to conduct a 95% interval for the means dissolved organic, blah, blah, blah. So what is, I'm going to start putting these Excel, but what does that say in there? I guess we need to know the answer for the first question, right?
There are 4 types of confidence intervals this below. Which one is
I think it's maybe the first one.
The standard deviation is unknown.
Yeah.
But is the standard deviation unknown?
Well, we can get the sample standard deviation, but we can't get the actual standard deviation.
Oh, I see what you're saying.
Right? Because isn't the sample standard deviation S, not O?
Maybe.
No, that's yeah.
There's so many symbols. I always get them mixed up.
S is on regular testing, but this kind of testing, the standard deviation is the that O with the little.
Well, because we know this, but I don't know. I thought we do know the. Let me think here. So we know the confidence intervals. We know the margin of error. What we don't know is I don't know why, but I'm not wrapping my head around this one. So is everyone okay with A?
It seems to me like I remember the book saying that we only ever know the actual mean and actual standard deviation when they just tell it to you. Anything that we calculate is always the mean and standard deviation of the sample.
Right.
Mm-hmm.
I agree with that. Okay, so let's stick with A, and we can always review it if we need to here.
Confidence
Okay,
interval
19
from
the
you.
following is the 95% confidence interval for this analysis. And we're going to determine the margin of error. The margin of error is 2.025. Change that to 2 outs in the ninth, 1 more out for the D. Dodgers.
Astro wins.
Lower bound is 11.168. And upper bound is 15.217. And they're both on my page if you 11.168 and 15.217. Okay. Everybody good with those?
Yep.
Wait, I must have blanked out or whatever. Whoa, what's happening? Oh, sorry. My thing was like, I don't know what's happening to my page really quick. Sorry, my page is freaking out. What was it for the 90?
Astro won. David.
Astros win the World Series.
The win. Sorry.
So for upper, we had the 15 points.
15.217 is the upper.
Okay, sorry. My screen was like freaking out for a bit, so I was like, no, wait.
You got the lower bound and you got the
lower bound was 11.168.
Perfect.
Okay. Hamner used Hamner in YLA.
That's awesome. Boo, Dodgers. Okay. That's rad. Okay, I don't care about
There's two.
Okay.
Two. They'll win. Oh.
Holy cow.
No.
Used Hummers, and this is a weird one. There's all sorts of information. Okay, so let's look what we want. Random samples of Hummers for sale in LA and New York were taken from a list at cars.com. We want to know the difference in mean list price between the Hummers for sale in Los Angeles and the Hummers in New York. Create a 95% confidence interval for the true difference of mean listing prices between the two cities. So here's that question again.
Those are independent, right?
This is a paired.
I think it's,
There's a group 1 and a group 2.
but they're The sales in Los Angeles aren't paired with the ones in New York. They're just two different independent samples, right?
Okay.
I believe so, yes.
So you're saying C, chart.
Yeah.
Okay, calculate the 95% confidence interval for the true difference of mean listing prices between the Hummers in LA and New York. Okay, so let me put these in. LA and New York. So there's Hummers. These are all on the list.
There's Hummer.
So LA, copy those, and this is a 2-sample t-test, correct?
Yes.
Paste the values there.
Oops.
And the ones in the New Yorks. Yeah, because the New York is a lot less sales than the ones in
LA.
Yeah. So we don't. So yeah, it's definitely not a paired because you'd have a lot of no pairs. Okay. So what's our? So then we have 95% confidence level. We don't have a test yet, right? We don't know if it's whatever. So lower bound. Lower bound, I have negative 423.238.
On 423.
Negative 423.238.
Mm-hmm.
Upper bound, I have 5417.336.
Four one seven.
That's all we're using for that. Okay. That was quick. Okay, next questions. We have another set of bone density thing. And our first question is, again, what kind of test are we going to use? So, one study examined there were 3 groups, a control with no jumping, a low jump group, and a high jump group. After 8 weeks, 5 per day, the bone densities of the rats were measured. The data was recorded. Researchers would like to determine the mean levels of bone density of difference between the 3 groups. And So what is the correct test? So is this an ANOVA? Because there's 3?
Yeah, I think so.
Mm-hmm. Yeah. Hold on, let me see.
Calculate the test statistics. Let me enter this into our stuff real quick. ANOVA. So we're going to get rid of variables 4, 5, and 6. Variable 1 is going to be the control group. Variable 2 is the low jump group. And variable 3 right? So it's asking us for the t value, right? Test statistic.
Mm-hmm.
Which is, where's that at on this ANOVA thing? The f value or the p value?
Well, it's not the p-value.
Is it the f, the 7.987?
Just a sec.
I'm not sure.
I put my Excel on I shared it, so if you guys want to look at it.
Yeah, I don't see it. It could be the F, I guess.
Just a second, I'm trying to find.
I zoomed in a little bit for you. Right? It would have to be the F, right? Let's use the Google.
The P value is, what's the P? 0.00.
ANOVA, right? The F statistic is the. I think that's it. Yeah. So I just Googled test
The F.
ANOVA and it says the F statistic. So I think it's the F. So it's 7.987. 7.98. Excuse me. I was getting a little dyslexic there. 7.978. 7.978. You have the p-value, which is 0.002. And then which of the following is the best expression to conclude the test? Well, this is the one where this was the one where we needed to, I'd like to add this to the thing, right? So this is kind of the same idea, right? So what's the idea of, remind me what the idea of alpha is, right? So if we make an if statement, if the p-value is less than or equal to alpha. I'm just going to make that here. Then what's the saying?
To then reject the.
Well, no, it's different on an ANOVA. Remember ANOVA? It's
that's right.
You just do QQ plot to determine that, isn't it?
Say that again.
We need to do the QQ plot thing.
I don't think so, do we?
That was this Monday we were discussing about that. So let me see if I can get the QQ plot thing.
Right, I see what you're saying. There was that. Yeah, it's not just a p-value thing. It's more than that, right?
In order for you to determine, because if you see that the one of the samples are not, there's a word in there. Let me go back to lesson 14.
QQ. But isn't there like, so the p-value and the alpha, is that the one that determines if there's sufficient evidence or not? And then the QQ tells you about if one's off or not?
Yeah, the QQ has something to do with
It's the different mean thing, right? If it's on the line, good. If it's off the line, bad. But the insufficient evidence, isn't that to do with the p-value versus the alpha?
Hold on, you got cut out.
Anybody? Bueller?
Degree of freedom, blah, blah, blah. P-value is greater than, we reject, if the p-value is greater than the alpha, what do you call it? We reject the null. There is a sufficient evidence to suggest that at least one of the three groups has a mean level of satisfaction. But if
that was if it's greater than, right?
Yeah.
Say that one more time again.
So
it says there's sufficient evidence or not sufficient evidence?
There is sufficient evidence to suggest that at least one of the three groups has a mean level of satisfaction with life, satisfaction. So and that is if the p-value is greater than the alpha.
Okay, so it says there's sufficient evidence to conclude that at least one of the groups has, say it one more time, has
a mean level of satisfaction.
Then what does that mean when it's
so here's the bottom one. It means that the levels of satisfaction is not the same with all three groups. One of the level of the satisfaction is not the same as the rest of the group.
Right. So, but then what does it mean when it's above? So when it's less than. So if it's less, the p-value is less than, like in this case.
So let me see what's the option. So number 2 or 3?
So are we just trying? So on 20, are we just trying to find out what we think is the answer, or like trying to get the answer?
Right now, I'm trying to just understand if the p-value is less than, what does it mean? If the p-value is greater than, what does it mean? Just in the generic idea. I'm trying to add it to the ANOVA table real quick.
Hold on, let me just do the.
So if it's below, does that mean there's insufficient evidence then?
I think it does.
Let me just check the QQ plot on here, just to be safe.
You're not? Okay.
And then sort. David, you need to get ready to bed.
So do I.
Well, this. Hey, if you don't take that off, turn that off right now, you're gonna lose your computer time. All right.
Does anybody have any luck finding the definition of when the p-value is less than?
So, based on this QQ plot, so I'll pick C on this one.
Wait, on 28, we're gonna go. You're thinking it's C?
Is that
Oh,
28?
You guys remember this other thing with, I'm reading some other stuff. Remember, wasn't this also, there was something to do with the, what was it, the means, the square mean square. If one's 4 times the other, then that's a bad thing or something. What was that on? Because this one is, because within groups is 4 times different than the between groups. I can't remember, what was it, or was it the sum of the squares, or what was that one thing that was like if it's 4 times? Do you remember that?
Oh, yeah, let me find that.
So I found something on the internet that says when you're comparing in ANOVA, if the p-value is less than your significance level, you know that some of the group means are different, but not which pairs. So I think Marie is probably right that at least one of the other groups is different.
Mm-hmm.
Wait, so with one of the groups being different, would that make it C or would that make it D?
I think it's C because at least it says some of the group means are different, but you don't know which pairs. So at least one of them is different.
Yeah, and the margin, the in between those 3 samples, their difference is not that 4 times.
But look at, so C and D essentially say the same thing, but one says there's sufficient evidence and one says there's insufficient evidence. So where do we know what are the insufficient versus sufficient evidence? I guess that's something.
So I think The insufficient one is saying that we don't know if something is different. But what I'm finding on this site is saying we know that at least one of them is different. We just don't know which one. Right? Because if there was insufficient evidence, then it's a possibility that they're all the same.
Right, but I guess so. What shows that we have? That's what I'm trying to understand again. And I know we just went over this, and it's what tells us if we have sufficient evidence or not. What thing are we looking at to say we do or don't?
The p-value is less than the significance level.
Okay, so the p-value, so all the p-values doing. So stinking. My head's smoking, I think, right now.
Here, I'll
Hold on.
copy and paste this.
Let's
see.
So this is another interesting thing that I'm seeing. There's talking about the F value and the F value and the F statistic, which I don't think we get on our thing, right? We just have an F.
So I sent what I found in the chat.
If your one way another p-value is less than your significance level, oops, it just went away.
Okay.
Where's the chat at? There it is, chat button. So you know, right, I understand that. But I think there's still, I think it's a two-part thing, if I remember right, that there was like, one thing was about having enough evidence or not, and then another thing was about having the difference or not. Am I just totally misremembering something?
I don't know.
Because everything I keep finding on the internet talks about the F value and talking about the F statistic versus the F value, which I don't see, because it's like, oh yeah, if the F value obtained is greater than or equal to the F statistic computed, then there's insufficient evidence to reject the null hypothesis. But if the value is less than the F statistic, then there's sufficient evidence to reject. So it's like, but where's...
So is it, I wonder if we are looking at alpha and what's the other thing? Alpha and the p-value, but I wonder if that's the same thing as the F statistic and the whatever.
But the F statistic is way...
Plus statistic.
Okay, never mind. I don't know.
Was this just last lesson? Was it 14 that we were just going over this?
Yes, uh-huh.
Okay.
Yeah, I'm pretty sure.
It's higher if the p-value is higher than the alpha. The significance level of significance is
Yep.
all three groups. So, but if it is less, so what? So there is a sufficient evidence that conclude that mean bone density. It's different. Let me see.
Okay, here we go. So determine if a population variances are equal. Use a very simple trick. Check. If the largest variance is at least 4 times as big as the smaller variance, we will conclude that the population variances are not equal. Okay, so if we look at our variances here, that's not the case, right? So none of these are 4x, right? We have 275 and 750. That's not 4 times. If the largest variance is not 4 times bigger than the smallest variance, we will conclude that the population variances are close enough and that we can assume that all variances are equal. This is from our book. So it's not that, so they are equal according to that to determine if they're equal.
Yeah. They
But
are
then again, I'm looking
equal.
for how do we know if it has sufficient evidence?
Do we want to just do where one of us does C and the other one does D?
Let me just see if I can find something right here real quick.
To conclude that the mean bone density of about the same.
I think it's D.
There is a sufficient evidence to conclude that the mean bone density of all three groups is about the same.
The one before that.
Yes. Because the other one is not, the higher is, what do you call it? It's not higher than, it's not 4 times higher, and it says it should be, and yet our p-value is less than, so it's not, because if it is, the p-value is higher, then at least the other group is, that should be the answer if the other one is.
There are two. Okay, I think I got it. Okay. If you look at step 4 in the homework from last week, it says, okay, so you talked about the QQ plots, but it says, okay, the largest variance is not 4 times the smallest, which is where we're at right now. So it says we can conclude that the variances are equal for the 3 groups. So I believe that is what lets us know if we have sufficient evidence or not. I think that's our sufficient evidence or not. We have 4. If it was over 4 times, then we would not have sufficient evidence because the variances would not be equal. Then the p-value, if the p-value is less than our alpha, which it is, then we reject the null hypothesis. Then it says, therefore, there is sufficient evidence to suggest that at least one of the 3 groups has a mean level of satisfaction that differs than the others. So in this case, so if you look on step 4 of our last lesson, lesson 14, there that question is almost identical. I mean, it's as far as the numbers aren't all the same, but it's the same as far as the variances are within range, the p-value is lower, and that's what they got. So I think that's going to be, we have sufficient evidence, and then yeah, so I guess it is. So for sure, I think it's D. But if you want to understand a little better, that step 4 looks like actually step 4 and 5 really in the ANOVA test really kind of push it out there. At least they did for me. So I'm good with D.
D.
All right.
Ooh,
D or C?
Delta D.
Okay, you didn't mark yours D.
There's 5.
Oh, there's 5?
Yep. There's an E.
Oh, shucks.
Okay.
Yeah, I was looking. I think my eyes is tired.
Ooh, that was a long one. Okay. We have a new set of information.
Don't know.
Perform a hypothesis test to determine if there's any difference in the mean cost of nonstop flights when tickets are purchased 14 days in advance versus 90. Use the level of significance of 0.10 for the next 4 questions. Do 14 days minus 90 days for the analysis. What is the correct hypothesis test for this situation? So this would be a paired.
Oh, sorry. I was just saying, from what I'm looking at, would this just be a dependent samples test?
I would
I
think
believe
so.
so. Yeah.
Okay. So calculate the test statistics, which let me put this in our Magilio. Holy cow, hold on a second. Oh, wow.
Sorry, one of my classmates asked me what formula did I use for information.
Shoot, what the hell?
Okay, so this is a paired.
Sorry, my little guy, if I'm not paying attention, he won't go to bed.
And I'm doing the Excel on my shared screen if anyone wants to follow along here.
Just put it there for now, please.
Okay, so there's our information.
Okay.
Except that we are now 0.90, right? And not right? It was a 0.90, not a 0.95.
Yeah.
And then we're not doing a hypothesis at this time, right?
No.
What's our answer for question 29? Sorry.
Not done it yet.
So
29
is dependent.
dependent. Yep.
Dependent sample test.
Yep.
Okay, sorry about that.
Oh, you should be sorry.
And that
Okay,
one
test statistics.
One of my classmates decided, I asked them if they have questions about the spreadsheet, and they said, no, they're fine, and now they're asking me a question about it. So.
Okay, did you guys get that? T value is 1.685. The P value is 0.096.
Okay, P value is 0.096.
And then I have it as fail to reject. So
would this be? Wait a second. I thought. I'm iffy. I'm looking at them like maybe it's B, but B. I'm thinking maybe B, but I'm not sure on that. Now that I'm looking at it, but
it's saying that there is. So I think it's C, right? Because it says that fail to reject the null. Like it's too close, right? Because we have a 0.1 alpha, and our P value is 0.096. So it's less than. So we fail to reject. So we have sufficient evidence to conclude that there is no difference.
In the mean.
Right? Because that's fail to reject is saying that it is the same. We answered 23, and I just didn't say it. Yep. Okay.
Wait. Hold on. Question.
Yes.
We do reject, don't we?
I have failed to reject because it's less than. Or excuse me.
96 instead of 0.10.
Do I have this backwards? Stand by. So I have it fail. So if it's less than
Seriously?
H23, hold on. So this is why you wanted me to check this stuff, because I have something wrong in my formula. 9. Reject the null hypothesis. Thank you. So Gavin was correct, and Sam fixed my thing. So thank you. So that is, so there is a difference. So yeah, so it is B. Bravo. Thank you guys for catching that. And I fixed my little test there. Okay. So you reject. I'm going to go ahead and try to submit, and then you guys can see what happens here. See how bad we are. Yeah, we got some wrong. Oh, we got one wrong.
Which one?
Haven't found it yet. These 0.5 ones throw me off because they're zeros. Oh, look at that.
Number 2?
Question 2. The easy one.
Wow, way back at the beginning.
Number 2.
The true mean then?
So maybe, yeah, true mean, maybe.
So somebody want to change that to delta, one person.
Wait,
Okay.
Will it be by chance B?
Hold on, let's have one person, let's have Sam change that to, what do you think, delta?
That's what would be my second guess.
Okay, let's have Sam change it to delta, and then Sam go ahead and turn it in, and then you guys wait.
All right. Submit. That's wrong.
So is it B, Bravo?
Yeah, let me check that one.
I think it's B, honestly.
Let's see. So one of you two do B.
I can do it. Wait, what's the answer for number 28 again? For some reason, I don't have 28.
So Marie, do Bravo, Marie, and turn it in. Gavin, 28
Okay,
is.
let me just do that.
28 is D. The fourth answer.
And then we have 32 as C.
So I'll
B, Bravo.
let me turn it in just a sec.
Gavin, it's B as in Bravo for 32.
Then I'm gonna submit mine.
Well, I guess we'll know even if you both submit it because there's only one possible answer after that.
It won't submit.
Okay. Wait, which one did I miss? I thought.
What did you miss? Why it's not working?
Oh, what was 3? I for some reason got 3 wrong.
It was C.
Oh,
Mine
for some reason I have
not
it.
submitting.
So, but was it B then? Bravo was number 2?
Yeah, it was Bravo, yeah.
Cool. Well, I think we're good to go then.
Mine is not submitting.
You guys just want to submit already. Do we need to reread it, or I just usually open a second window and just kind of copy my own stuff to it for a second time if you guys want to get 100%.
Yeah, that'll be good. I can do that.
So does anyone need to stay on, or
No, I think we're okay.
Marie, are you good?
Hold on just a sec.
Hey,
Let me check.
I still have to do finish a paper or 2, so I'm going to head out. If that's okay.
Yep. All right, Gavin.
That's fine.
Hey, thanks for everything, guys. I hope you do well on the test.
Yeah.
Okay, I didn't save my number 28.
Okay, 28 is. Now I can hear without all that popping. D is in Delta.
Okay, the last few didn't save on me. Number 29 is dependent sample test.
Dependent sample. And then 1.685.
1.685.
0.096.
0.096.
B is in Bravo. And that's it.
Okay. Let me check my number 2.
Number 2 is also B as in Bravo.
Yeah.
Okay, gonna go get that one question right and go through this whole darn test. I don't know if that's worth it, but it's a free 1 point, right? Might as well.
Yeah.
I'm not the only idiot doing that, right?
Oh no. Oh no.
Where did I miss?
You missed one?
Number 28.
Can we just
Well,
go over that one?
like the last one. Well, I can redo it later.
Well, thank you for Sam. Thanks for catching. Well, you caught a couple of them this time. There was a few that we had totally wrong, like that one. You're like multiple choice doesn't sound close.
There wasn't anywhere close.
That 38,000 one.
Yeah. So, and my other.
And what's funny is I think if I would have gotten 38,000, I would have said, "Oh, I did something wrong."
Yeah.
That's funny.
All right, are we good?
Yeah, we're good. I'll just redo mine. It's easier if I'll go through quick, carefully. And this is not due until tomorrow, right?
What was that?
This is due until tomorrow, so I'll work on it.
All right.
Yep.
So I'll work on it in a few. Let me just help my other classmate.
All right. Good night, everybody.
All right. Good night.
Good night. Thank you. I'll post the link.
All right. Thanks.